So today we are going to talk about string in Rust. So in Rust there are two types of string. You have the string literal, okay, and then the string object. The string literal is also called the string slice. Okay, it is stored in the binary and does not change. You can only have access to it as a reference. Okay, while the string object is stored in the heap. It can grow however you want. So when you use it, when you have a variable of type string, you can keep updating the value, adding more value, and removing values however you want. However, for the string literal, you can't do that. So let me give you an example. Let's say you have a string. Okay, for the string literal, it will be of type string, and then we set it to the value hello. Now this hello will be stored in the binary once the code is compiled, and then when you use this variable, you'll be reading this value from the binary as reference. Okay, but for a string object, you can create it this way. You specify that it is a string, and then there are many ways you can create it. For example, you can create an empty string object by using the new key associated function inside the string struct. Okay, this will create an empty string. Now, secondly, you can create a string from a string literal by just saying from, and then you provide the string literal. You can even use this one we've created up here. Okay, now we've created a string from this string literal. Now the string literal and the string are similar in many ways. First of all, they store strings. However, they approach how they store strings in different ways, differently. So this one will store it in the binary when it is compiled. However, for the string object, it will be stored in the heap, and then the pointer, the capacity, and the length will be stored in the stack. However, for the string object, it can grow. It means you can add new values to it. You can append more values to what you already have there. For example, you can access word and then push new values into it. For example, you can say hi in here, but we'll have to make it mutable so that we can change it, or we can add more values to it. However, for the name, which is the string literal, we can't do it. So once you create it, that is what it will always look like. It's actually a static variable, okay, because it's stored in the binary, and it will always be valid throughout the duration of the code. Now, for the most part, you find yourself having to use strings, especially when you want whatever you are doing to grow. Let's say you are accepting an input from the user. One user might provide a very small text, while the other user will provide bigger text. In that case, you use a string object. Now, so I told you that both the string literal and the string object are quite similar, and that is true. You can convert one from each other. For example, you can convert name, okay, which is a string slice, to a string object, and you can do the same thing vice versa. For example, if you want to convert this word, which is a string object, to a string slice, then all you have to do is to type in word dot as string, okay, and then you would have succeeded in converting it to a string slice if there is any reason to do that. So where this comes in very handy is usually when you have a function, okay, that you will see. Let's say we'll call this say hi. Just say it accepts text, and this text will be a string literal, okay, and it doesn't return anything. And then in here we'll print to the terminal whatever the user has provided, or whoever called that function has provided. We created a function with the parameter test that will be of type string literal. Now, we can call this function using a string and also using a string literal. Okay, for example, from here we can call say hi, and then we'll pass word to it. You can call the say hi function and then pass the strange. Okay, so this strange object, you can pass it here as reference because that is what it requires. But you will notice that this is a string literal. However, we are passing a strange object to it. So they work hand in hand in some ways. Now you have to be careful about using the length variable. For example, let's print out the length of this string literal. So we say num.length. Now this length will give you the length in bytes of whatever the string is. If you run this code, you get that the length is 3. However, one mistake beginners make sometimes is that you will think that the length will give you the number of characters inside the string, but that is not what happens. Okay, and to demonstrate that, let me give you an example. Remember that characters take up 4 bytes in the memory because they are UTF-8 encoded. However, many English characters do occupy just 1 byte. You know, they fit in the ASCII character encoding, which requires 8 bits. They also do the same thing here. So even though a character might occupy 4 bytes, if the particular character does occupy 8 bits, then that would be 1 byte. Then it will still occupy 1 byte. In this case, it means since we got 3 right here, it means that the word full occupies 3 bytes. Okay. Now, some characters like emojis and all that do occupy more than 1 byte, and I'm going to show you an example. So I will duplicate this and then paste this fancy F character here. So you can see that this F character and this one are not the same. This one is like a fancy font, okay, but it occupies 2 bytes, not just 1. And you can see that if I comment this out and then print the length of this variable again, you find out that the length now is 4, while the character, if you count it, you still find out that it's 3. Okay, so this can be confusing sometimes. The length is not the length of the characters, but the length of the bytes they took. So one character can take more than 1 byte. Okay, and that will affect the length. If you actually want to get the total characters of the variable, okay, what you can do here will be to get the characters, okay, and then you call count on it. Now this will get the characters and then count the number of characters you have there. You can see if we run that code now, it will give you 3. So this is the correct way of doing it. So if you want to count the number of characters in a string literal, it's better you get the characters first and then count them than using the length associated the length function. This will count the number of bytes the string occupied. Okay, there's another important thing you have to understand. The string object, even though it's being stored in the heap, we'll also have some metadata of it stored in the stack. Let me give you an example. Let's say we have this string, okay, that will store hello in it. Now this is a string object. This value will be stored in the heap, and subsequently some metadata of the heap's location will also be stored in the stack. And there are 3 things that are actually stored there. First, you have the pointer, and then you have the length, and then you have the capacity. Now the pointer will represent where this is stored in the heap. So the heap is just a stack of memory. H will be stored in one location, E will be stored in one location, mostly serially. So pointer will point to the first location where H is stored, and then the length will represent the bytes that the string occupied. Okay, in this case that will be 1, 2, 3, 4, 5, since each of these will occupy 1 byte. Okay, while the capacity will represent the amount of memory in the heap that Rust has reserved for this string. Okay, if we created a new string that is empty this way, Rust will not provide any capacity for it, so the capacity will be 0 because it's not going to reserve any memory for this since the string is empty at this point. Okay, now let's print this to the terminal and see what they hold. Now we've stored the pointer, okay, of this empty string in this variable, and then we've stored the length by getting the length, and then we've stored the capacity, and then let's print that to the terminal. So now we are printing the pointer to the terminal and then the length and the capacity. You will also notice that we have to provide a different format for the pointer, okay, so that it will also be printed to the terminal. Now if we run that code, we get the pointer is this. This is a hexadecimal number representing where this value is stored, okay, in the memory, in the heap. The length will be 0 because we don't have any string in it, and the capacity will be 0, which means Rust has not reserved any memory for this. Now if this string has some value, like if we created this and we say hello, watch what will happen. Now the pointer will be, this is where the string is now pointing to, okay, in the stack, the hexadecimal representation, and now the length of the byte is 5, and the capacity, the amount of memory Rust has reserved for this variable, is actually 5 bytes. Okay, so this goes to explain that these values are stored in the stack in order to be able to get the value hello from, this has to be hello, in order to get this from the heap whenever you want to read it. Now let me demonstrate something about the capacity. Now let's say we have a string that we call name, okay, and then we set it to an empty string. Now and then we have a for loop, okay, and we'll loop through it 5 times, and for each time we add something new to this name. Therefore we have to make this mutable. Let's say we kept on adding the string hello, okay, to it. Now every single time we do this, we print something to the terminal. So this loop will run 5 times, and every single time we push the word hello to the name string. We've made it mutable so that we can modify it, and then we'll print the capacity for this name to the terminal. Watch what Rust will do right here. Now you find out that the first time this loop ran, the amount of space reserved for this string is just 8. The capacity is just 8. But the more we push in more value, Rust will keep increasing the capacity to fit what we wanted to store. Okay, so this is how Rust takes care of storing strings in the memory.